Okay. Solving equations by factoring. So our first objective is to solve equations expressed as a product of factors to equal 0. So the very important principle here that we're going to talk about is our zero principle. Any rational number, a and b, so if a times b is equal to 0, then that must mean that a has to equal 0 or b has to equal 0. Or if a equals 0 or b equals 0, then our a times b must equal 0. So that's saying that, let's say if I had 3 times 0, well 3 times 0 is going to be 0. So if I had 3 times a, and I told you a is equal to 0, this is always just going to be 0. No matter what that 3 is. I could have it as 1,000,000, and 1,000,000 times 0 is still just going to be 0. So if our equation is set equal to 0, we're always going to then solve it for 0, because no matter what our equation equals, it's going to equal 0. So to be able to solve this, I want to set one of the two equations. I'm going to label this as equation 1 and this one as equation 2. I want to set one of my two equations equal to 0. So 5x plus 1 is equal to 0. Or I can set my other equation, x minus 7 is equal to 0. So I'm going to solve minus 1 from both sides. 5x equals negative 1. Divide by 5. X is equal to negative 1/5. This one I would add 7 and have x is equal to 7. So if I went and plugged, I have two answers. X could equal either negative 1/5 or 7. Because if I went and plugged in 5 times negative 1/5 plus 1 times negative 1/5 minus 7, and I want that to be equal to 0. Negative 1/5 times 1 is 1, negative 1 plus 1, and negative 1 plus 1 is 0. And 0 times anything, so no matter what this part equaled here, 0 times anything is just going to equal 0, so that doesn't even matter what that is equal to. So it's the same on the other side too. 7 minus x is still just going to be 0. Alright, so let's try this again. In something like this, I like to put my second set of parentheses right here. So now I have two sets of parentheses, and I'm going to set my first equation equal to 0. So my first equation is just x is equal to 0, or 2x minus 9 is equal to 0. So this one's all solved because x is equal to 0. So that's one answer I could have. The other could be 2x is equal to 9, x is equal to 9/2. So either answer that I plug in, I'm going to end up with 0. And so here are a couple thinking questions. 3a is equal to 0. Does a equal 0? Or 3 times 9, or 3a equals 9. In that case, could a equal 0? CD equals 0. Does C have to, I'm going to write a have to, equal 0? And C times D is equal to 18. Can C equal 0 in that case? And here are a whole bunch of problems for you to try. I know this one down here is going to be a little tricky. Set each of them equal to 0. So you have 3 problems that you'll set equal to 0.